Now that we have seen some of the principles involved in using a military map with a compass, let us see how they are applied in field situations. In the field, particularly under combat conditions, it frequently is necessary to determine a location which is not specifically identified on the map. This man, for example, sees this armored personnel carrier and wishes to report its location to his superiors. Although the APC is not in a position which is identified on his map, the soldier can determine its location by applying the principles we have just seen demonstrated and performing what is known as intersection. Intersection is used to locate points which are not designated on the map and is accomplished with a compass by sighting on the unknown point from two locations which can be identified. To illustrate, suppose that the APC we just saw was located approximately here. We first observed it from this road junction. To identify the point where it is situated by means of intersection, first we note our location at the road junction on our map. Then we sight our compass on the unknown position and record the magnetic azimuth of 145 degrees. Next, we move to a second known position from which we can see the APC, a position about 90 degrees from the first. We will use this road junction. Again, we note our position on the map and sight on the unknown point. This time, the magnetic azimuth is 205 degrees. We record this figure on the map, and our next step is to convert magnetic to grid azimuths. So we refer to the declination diagram for the GM angle. In this case, the total variation between grid and magnetic north is 5 degrees west. This is our GM angle. By studying the diagram and remembering that azimuths are always measured clockwise, we can see that magnetic azimuth is greater than grid azimuth. This means that we must subtract the GM angle of 5 degrees from our magnetic readings to obtain grid azimuths. The grid azimuths will be used to plot the point at which the APC is located on our map. For this plotting, a protractor is used. Protractors come in several forms, but all of them divide a circle into units of angular measure, in this case degrees. A scale of the degrees within a circle is printed around the outer edge. In the center of the protractor is an index mark. To plot the position of the unknown location on our map, we first place the protractor with its index mark directly over one of the points from which we sighted on the APC. 0 on the protractor must always face grid north, and the index lines must run exactly parallel to the grid lines on the map if plotting of the grid azimuth is to be accurate. When the protractor is precisely placed, we read the grid azimuth obtained at this location, 200 degrees, and mark this point on the map. Now, with a straight edge, we draw a line from the observation point directly over the 200-degree mark toward the unknown position. We then read the grid azimuth obtained at the other point, 140 degrees, located on the protractor, and mark it on the map. Again, using a straight edge, we draw a line from the observation position directly over 140 degrees toward the unknown location. The spot where the two drawn lines intersect is the location of the APC. On our map, it can now be read and reported as coordinates 387113. This is how you can use intersection with a compass to obtain the reportable location of an otherwise unidentified position on your map. But what if you are in an unknown location and need to find your position? How can you do this? It can be done by means of what is called resection. It is performed by sighting on two features which appear on both the ground and the map. To illustrate, you are somewhere in this area and need to know your exact location. From your position, you can see this church and this farmhouse, both of which appear on your map. After you have oriented your map, you sight on the church from your position and get a magnetic reading of 320 degrees. You note this on your map beside the church. Then you sight on the farmhouse and obtain a reading of 40 degrees, which you mark on your map beside the farmhouse symbol. Now you must convert these two magnetic azimuths to grid azimuths for use on your map, so you refer to the declination diagram. The GM angle is 5 degrees west. This, you can see, must be subtracted from your figures to convert them to grid azimuths. But even these grid azimuths do not enable you to determine your location on the map. For that, you must have back azimuths, which are in effect the azimuths back toward you from the points on which you have sighted. Back azimuths are obtained by adding 180 degrees to any azimuth which is less than 180 degrees, or when an azimuth is more than 180 degrees, by subtracting 180 degrees from it. With the back azimuths thus obtained, you are ready to determine your position. To do this, position your protractor on the map over the feature you first sighted on, the church. Then, on the protractor scale, locate and mark the back azimuth you have obtained for this location, 135 degrees. With this completed, remove the protractor and with a straight edge, draw a line from the point on which you sighted the church back toward yourself, passing through the point marked at 135 degrees. Then repeat this process at your second reference point, the farmhouse. Be certain that the placement of your protractor is correct. Then, on its scale, locate and mark the back azimuth you have for this position. It is 215 degrees. Remove the protractor and with a straight edge, draw a line from the point on which you sighted through the dot indicating its back azimuth and on toward yourself. Where the two drawn lines cross will be your location on the map. In the field, resection to locate your position on the map is performed in the same way. We have seen how to use a compass to orient a map, determine directions, and identify unknown locations. Now let us observe how it can be used to get you across country. This man is here, in this barnyard at 104-673. He must get to Chickamuxon, here to rejoin his platoon. For tactical reasons, he must avoid this highway, which means that he will have to go across country to reach his destination. To use his map and compass to get him there, the soldier first places a straight edge on the map, connecting his present location with his destination, and draws a line along it between these 2 points. Next, he positions his protractor with its index point directly over his present location and its index lines properly parallel to the grid lines. He then reads the protractor scale at the point where it lies over the line he has drawn, in this case, 265 degrees, and notes this figure down. But remember, this is grid azimuth, and to use his compass to follow it, this figure must be converted to magnetic azimuth. The declination diagram tells the man that the GM angle is 5 degrees west. and magnetic azimuth is greater than grid azimuth. So he knows that to obtain magnetic azimuth, he must add the value of the GM angle to his grid reading. This results in a magnetic azimuth of 270 degrees, and the soldier is ready to set his compass for cross-country use. He first rotates the compass until the line indicating 270 degrees lies directly beneath the black index line. Then he turns the bezel ring until the long luminous line on its crystal lies directly over the north-seeking arrow. Now his compass is set for the desired azimuth, and he is ready to move. The soldier will hold his compass where he can read it conveniently, approximately halfway between his chin and his belt. In this position, it has been demonstrated that the compass will not be affected by any metallic equipment he may be wearing. With the compass in place, the soldier now slowly turns until the arrow is directly under the long luminous line on the bezel. Now the azimuth, 270 degrees, will lie directly under the black index line and in line with the compass sighting wire. By following the line thus established out over the front cover, the compass user can determine his azimuth. If a landmark which can be kept in constant view lies on his course, it may be used as a steering mark. But even when no such reference points are available, the soldier, once he has set his compass, can maintain a direct heading toward his destination by frequently referring to his compass, checking his course, and resighting along the route. However, be careful when taking readings not to have metallic objects, such as the helmet, too close to the compass. At night, the compass may be used for simple land navigation in the same manner. For this purpose, it has certain luminous features not discussed so far. These are all visible in the dark and include the line on the bezel glass, the north-seeking arrow, letters indicating east and west, and an area directly under the black index line for reading azimuths. In addition, the compass cover contains two luminous dots, one at each end of the sighting wire. When the compass has been set with the azimuth directly under the black index line and the long luminous line directly over the arrow, it is ready for night use. Rotate the compass so that the arrow lies directly under the luminous line. Then sight along the line indicated by the two luminous dots at each end of the sighting wire, and this will indicate your azimuth. If it is light enough to make out steering points along your route, make use of them. If it is so dark that none can be seen, send another man out along the azimuth line as far as he may be seen. Then sight on him, move to his location, and repeat this procedure until you arrive at your destination. If neither of these aids is available, continual reference to your properly set compass will accurately guide you to your goal. These, then, are the basic principles of using a map and compass in the field to determine locations or to guide you across country by day or night. Learn to apply them by study and practice, and you will be arming yourself with knowledge and experience which may someday be the key to a successful mission.